Hello, everybody. We are back with the secant-secant relationships from our GeoGebra activity. I've taken the liberty of drawing a couple secant segments and putting some measurements on there in terms of the side lengths, just to make things speed up a little bit. I know we've all played around with this already, and hopefully you've come up with some good things when you've played around. What we have here are each individual segment, and then FE, would represent the entire secant segment from the point E. GE, of course, the entire secant segment from point E also. So as you're playing around, we've talked about using the calculate tool here. I'm just going to get right to it. If we go ahead and we look at the length of HE, so from the point E, the common point E, to the point H, and if we multiply this by that whole segment FE, we'll get this 66.7 here. Well, not sure what that means right now, but if we take a look at these two numbers, they look like they might multiply and be something really close to that. So let's see what happens. Let's take IE times that entire length from E. And look at that. These two products are equal to one another. We move the point E around, we see that those two products are still equal. We make our circle bigger, those two products are still equal. Change where the center of the circle is, the two products are still equal. Therefore, we can conclude that from point E, we have the product of the segments that emanate from E to each portion of the circle would be equal. Or, in other words, if we look at the diagram that was given to us, we would have, let me get a text box here, we would have that W times W plus X would be equal to Y times Y plus Z. And so if we are looking at the diagram that was given to us on our worksheet, this is our conclusion that we should come up with for those segment lengths in a secant-secant angle. Right here is the formula that we know from the segments of a secant-secant angle.